Hello guys, welcome back to the channel again. Today we will solve the 7th question of July Leetcode challenge. So our question is island parameter. So video will be divided into 3 parts. First the question explanation, second the solution explanation, and third the code explanation. So what we have to do, we have given a 2D array which is a map in which 0 indicates the water and 1 indicates the land. Now we have to find the parameter of the land. Now how we will find the parameter? Suppose we have this as a matrix. Now this one, these all ones represents the land. So our world or our matrix will look like something this, in which the brown indicates the land and the blue indicates the water. So now we have to count the parameter. Now how the parameter is initialized or how a parameter can be considered, the logic is that we have to surround all the island by a parameter. A parameter is a thing which covers your full shape. So in this, if we want to cover the shape, what we should do, we should go from here and down, then right, then left, then like this whole island we have to cover. Now we have to count the segments, how many segments required to make a parameter. So in this is first segment, this second, third, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there are 16 parameters required to make these island parameters. So we will consider our answer equals to 16. Now one big observation or one main thing in this code or in this question is that there does not have any lakes. Now it states that none of the 0 will come in between of 1. Means 0 will not be surrounded by 1s in at any condition. Now in this case this 0 is surrounded by 1 1 1 1 1, but one side there is no 0 or one side there is no 1 and zeros. So we will consider this as a water only. So this we will consider as water, these whole side parts. So if we have this land, so we will consider this matrix as a land only. So we will take this as a land. So this is how we have to calculate the parameter, and now we will discuss that how we will calculate the parameter and all. Now for understanding the question or for understanding the solution and approach, we will take this as example. So in this, we all know that 1 represent the land part and 0 represent the water part. So first of all, if we want to find out the parameter of this, what it will be? This will be our first segment, second, third, fourth, 5th, 6th, 7th, 8th, 9th, 10th, 11th, 12th, 13th, 14th, 15th, and this is the last 16. So answer will be 16 in this case. Now suppose if only one is there and all other zeros are there, so what will be our answer? Our answer will be 4, because 4 required to wrap one number. So 4. Now let's consider one more thing. Suppose if it is like this, 1 1 here, 1 1 here. Now it will require 4 for this, 4 for this, but these 2 will be cancelled because this outer will cover. So what it will do? What we'll do? We'll multiply 4 by 2. So 4 multiplied by 2 minus 2. We will get our answer equals to 6. Similarly, if we add one more, for this also we require 4. Now this will be again cancelled and this will be like this. Now what it will be? It will be 4 multiplied by 3 minus 1, 2, 3 and 4. So answer will be what? Our answer will be 8. Now after this, suppose here also it is 1. So again we'll do the same thing. and again these 2 will be cancelled. So what will be our value? 5 into, sorry, 4 into 4 minus 6. So our value, what it will be? It will be 10. So now we have observed one thing, that if one or more numbers are connected, then 2 will be erased. Now if 1 is also here, so this will be erased. So now if we somehow find the connected nodes and we found the number of nodes, then we can easily do, how we can easily do? First of all, if we found the number of ones, in this case how many ones are there? First one, second, third, fourth, fifth, sixth and 7. So there are 7 ones. So what we'll do, we'll multiply 4 by 7. Now we will find the connected. So in this 1 is connected, this 1 is, so we will find the connected from these 1. So this 1 is connected from this connected, this is connected from this is connected from this is connected from this is connected from this, and this is connected from this. So how many lines will be there? This 1, 2, 3, 4, 5 and 6. So what we'll do, we'll subtract what? 6. Now we will not subtract 6 only, because there will be 2 lines at every position, so it will be 12. Now you should not confuse between 6 and 12. Why it should be 12? You all know, because there should be 1 line for this one and 1 line for this one. So there should be 12 lines. So our answer will, in this case also, it will come what? 4 into 7 minus 12. So answer will be 16 in this case also. So in this case also we will get our answer. Now the question becomes that we can easily count the number of ones. Now how we will count the number of lines? So this we will count by using a pointer, or by using one more condition, that is, if suppose we are on this one, then what we will check, that any connected node is there on left and bottom or not. Suppose we are on this number, now we will check that if connected node is there on left or not. If there is connected any node, so we will increment our second counter by 1. Again we will come on this one, we will check the same thing, so we will increment. Now if we come on 1, we have to check for 2, for left and for bottom, so we will increment them both. These both we will increment. So after coming to this, our answer will be 6 till here. So we have to just do 2 things. First of all, we have to count the number of ones, and second we have to count the number of left and bottom according to everyone. So now if we properly understand the question, so how, suppose this is our new matrix, or this is our matrix. In this 1 1 1 and 0 1 0 1 1 and 1, this is our matrix. Now we have to iterate over this matrix, or we have to count the number of ones first of all. So we will count this one, this. So our answer will be 7. Now we will count the number of left and bottom. So we does not require to count all the 4 things, top, left, bottom and right. We just require to count 2 things, first the bottom part and second the right part. Now it is a question that why we are counting the left and bottom only. Now if you start from this, sorry, we are checking for right and bottom, so don't confuse between left and right, it should be right only. Now I will explain that why we are taking right and bottom, because we are going from top left bottom corner to bottom right corner. That's why we are doing this thing. Suppose if you start from this index, it does not matter, you can take the top and left. Now if you start from this, you can again take top and right. If you start from this, you can take bottom and left. So it does not matter. Why we are counting 2 only, this we will understand with the help of this example only. So suppose if we count for this one, so there is only 1. Now this how many lines should not be make if one come. So there is only one, so we does not require to make one line. Now we will come on this. Now we will check for left, we does not require to make line here. Now in bottom also we does not require to make a line. That's why we are checking two things. Now it doesn't matter to count the left part in this. If you count the left part, already there is no line, so there is no sense for counting. That's why we are counting the right part and the bottom part. So in this also we have to consider one line only, so we will consider this because two will be skipped. Now we will do the same thing for this also. So for this we does not require any, so we will consider all the lines. Now we will do the same thing for this one also. We will check for bottom, so we will not take bottom part. Now we will again consider the same thing for this one, so these three lines will be constructed. Now we will take for this one also, so the same thing will again happen. Now we will take for this one also, so this will again happen. So in this also we have easily find it. So how many nodes are there? 7, and we multiply it by 4. Now what we have to subtract? We have to subtract the number of connected nodes multiplied by 2. So in this case, 1 left, 2 left, 1 bottom, 2 bottom, 3 bottom. So 1, 2, 3, 4 and 5. So there are 6 numbers. Why 6? This one will also come for this bottom. So there will be 6 multiplied by 2. So what it will be? It will be 12. 7 into 4, 28. So 28 minus 12, 16 will be there. Now if we count the number of lines, it will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. So there are 16 lines in this whole circuit or in this whole node. So there should be answer equals to 16 only, and by using this formula also we are calculating answer equals to 16. So now we have one formula that first of all we have to count the number of ones, second we have to count the number of right connected ones and bottom connected ones, and then we will multiply that count with 2 and the number of ones with 4. So now we will see our code and we will do this same thing using our code. So this is the code for this solution. So first of all I have initialized the right and down because I'm counting the right and down separately. It doesn't matter if you count together also. Now what we are doing, next thing, we are initializing the count, then we are iterating over all the grid, and at the end we have used that formula only, which will be count the number of ones multiplied by 4 minus right plus left multiplied by 2. So this will be our standard formula which we will use. So first of all we will iterate over each and every value. On every value what we will check if the number is 1 or not. If the number is 1, then we'll initialize the count which will keep track of the number of ones. So this we will initialize as soon as we enter in the loop. So after this we will check two conditions. First, that the next element or the right element is 1 or not, and second condition we will check that the bottom or the next bottom element with the same row is correct or not. So in this case j plus 1 should be less than the size of this. Now what this is checking, that if we have 4 rows in our table, then this should be next equals this, then this 4 j can't be greater than 3. That's why this condition is checked, so that j should not exceed this. If the last element is there, then we will not check this condition, because then no other element can be there if it is on border. So this condition in this is checking the bottom part, or checking that the element is on the rightmost part or not. In this also it is checking the same, it is checking for the bottom one, that the element is there on the bottom or not. Now second thing, it is checking that if next is 1 or not. If next is 1, then we'll increment the right, and if the bottom is 1, then we'll increment the bottom. Now why we are checking the both in one thing? or why we are checking that both separately. We can check in one also, but the problem is that if suppose a number is there 1 1 1, so in this both right and bottom both have 1, so we have to increment for both ones, because these both lines and these both lines will also be not considered. That's why we are checking for these both. So now we will submit our solution. That what will be our solution. So this is the code which we are going to submit. So first of all, you must see these two lines which I am using to avoid the useless test cases in which 0 or some null value is given as an input. So that's why this line is used to increase the time complexity or time usage, or mainly decrease the time usage and increase or decrease the time complexity. So now if we submit our solution, we got correct answer. So this is the solution for the 7th question of July Leetcode challenge. Thank you guys. For more such content, like, share, comment, and don't forget to subscribe.